Hello everyone, the subject of our group is New York City Street Network and Taxi Traffic Analysis. Traffic analysis is not a brand new topic, but we do add some original ideas and methods during our research. Our project can be divided into two periods using the intermediate presentation as a boundary. Before intermediate presentation, we did feature extraction, such as finding which weather can provide shorter travel time. We did clustering, basically using k-means, and we also did data visualization and animation. These processes were mainly based on New York City Yellow Cab trip record data from 2016. According to the feedback from the intermediate presentation, we realized that we need some improvement in the dataset part. Therefore, after intermediate presentation, we decided to introduce more datasets, which are strong complements to the original dataset. Now, we have datasets from different resources. How can we combine them to do some meaningful analysis? Well, this is how we make it. For example, based on the original dataset, New York City Yellow Cab trip record data, we can have pick up location and drop off location. Using these locations, we can extract the shortest path between these 2 points from OSRM. Now, what about the street network data? The problem is that the number of nodes in the network graph is limited, but the pick-up and drop-off position can be anywhere. In order to solve this problem, we used a function named getNearestNode, which helps us find the approximately node on the graph. Great! Now, by combining these different datasets, we can get a more complete view of our data. Based on this data, we did prediction and graph analysis. First is prediction. We extracted the location features, did gradient boosting, and this is the prediction result. We had a more detailed description about it in our report. The other thing we did is graph analysis on the New York City street network. We know that a network can be roughly divided into 4 types: regular lattice, random, small world, and scale-free. Now the question is, what type of network that Manhattan Streets belongs to? Do you have any guess? Well, first, let's take a look at the single node degree distribution. We can see most nodes have 3 to 4 degrees. It's reasonable because Manhattan streets do have such a square structure. However, if we compute the in-degree and out-degree distribution, we can find it looks much like a Poisson curve, the yellow one in the picture. According to the paper, the network analysis of urban streets, a primal approach, a random graph exhibits a Poisson degree distribution. During our final presentation, the professor and the TAs kindly pointed out that it may not be random network for Manhattan Street network. Therefore, we used another way to compute the node degree distribution. Instead of using in-degree and out-degree, we used undirected graph, and this is the new node degree distribution. According to another paper, Collective Dynamics of Small World Networks, In a small world, a network exhibits a large local clustering typical of regular lattices. Based on this figure, we can make a guess that Manhattan's street network may be small world. Now, what about other graph properties of Manhattan street network? The diameter of the network is 88, which means traveling between two most far-away nodes in Manhattan needed to pass at least 88 edges. The average shortest path length is 35.05, and this is the node with the largest betweenness. We all know that largest betweenness means most shortest path would go through this node. In the street network, it would be extremely important. Let's see where it is. When we mark it on the map, we can find it's on the up east. It's a motorway junction near FDR Drive. Beyond and between this, we could also compute the shortest path of two nodes. Let's check some examples of them. The red line is the farthest path extracted from OSRM data. The blue line is the shortest path that I computed based on graph analysis. We can see some very interesting features by comparing them. Okay, in summary, based on these 5 different datasets, we did feature extraction, clustering, data visualization, data animation, prediction, and graph analysis. So, what's the business value behind our research? By combining the results of our 2 periods, now we are able to tell a passenger on a specific day, on a specific weather, how long it will take him to his destination, which vendor he should choose in order to have shorter travel time. We can also tell a driver what time in which part of the city there would be more passengers. What's the shortest path? Moreover, we can also figure out which streets are the key points in the street network. We believe the related departments need to pay special attention to these points, since a block or an attack on such a point would cause huge effect on the whole traffic network of the city. This is our presentation. Thank you so much for your time.